Quasar E-Motorsports. Hey, what's up guys? This is Quasar. Sorry for the delay in posting new videos. I've been waiting on hardware and I've been waiting on parts to build this CNC router for all the aluminum parts for the bikes. This is the Yu Queen Ant Pro version 2. I'm going to be using this base frame to build a router specifically for aluminum. Typically routers can only do aluminum in little bits, but this is going to be a super rigid version with a lot of custom stuff on it, so we can really push through that aluminum. I've got these super thick 40-80 extrusions for all the axes. The bed is a 20mm solid piece of precision ground Tslot 6061 aluminum. Actually, you know what? I think it might be cast, which is better. So yeah, we're using this to stiffen up the bed, and these are going to be to stiffen up the gantry and the bottom rails. And then the craziest part about this is this actually shipped yesterday. Came here from China literally overnight. It's unbelievable. Shipping was like $800 for these few boxes, and they said it was going to be 7 to 20 business days, and I got it overnight. It shipped, well actually it was supposed to ship on my birthday, and then it arrived at the facility after hours, so it actually shipped yesterday, and I got it today, which is just insane. But yeah, please do follow up on this video. I'm going to be building this on the channel, and you guys get to see what it can do. All right, stay tuned. All right, so we've got everything unboxed. Turns out these are actually servo motors. This is a hybrid servo motor, so it's a closed loop, I think stepper motor working like a servo, or maybe it's an actual servo motor. I'm not really 100% sure. Because I bought the control box kit, and I want to do that so I can have most of the wiring eliminated for me. All these are already wired up and plug right in. One thing that I did custom order with this setup is I wanted all these to be double shielded wire cables, and I wanted all the shielding terminated to ground in the box. And I pulled one of these plugs apart, and they have, the way they did it, they didn't put different pins on there. They use the existing ones, so they don't have a pin for the ground. But what they're doing here is they have that shielded ground coming back through here. You can actually see it right here. And it's touching the case of this, which touches the case on the input here, which grounds straight to the box. And on the other side of the plug here, it's got ground wires soldered on that are terminated to ground. So everything is double shielded and properly grounded, which is really big for any kind of CNC, because EMF will mess with your signals, and it can cause lots of issues. So it's best to just ground it and do it the right way first time. I'm actually really impressed. They did a good job. I would have used different connectors with that extra pin, but the way that they did execute it works just fine. So yeah, we've got pretty much everything here. These boxes are full of plates and hardware. This is the spindle, which is, I mean, it looks pretty nice. It's still a Chinese 2.2 kilowatt spindle. I haven't really inspected it too much, but it looks decent. I'm going to start with this. We're going to definitely upgrade that later. It came with a ton of collets. I mean, I think that's pretty much every metric and every standard up to 1/2 inch. Came with really nice cable chains. These things are nice and fat. This thing is, I mean, it's a monster. And it's fairly smooth. I did get the Rich Auto DSP. We'll be just giving this to somebody probably. We're going to be using the Maso G3 Touch, which is an amazing controller, and it's a 15-inch touchscreen, and you don't need a computer necessarily, so it's pretty fantastic. I am considering removing the VFD from this box. It is about 10 inches away from the closed loop stepper drivers, or hybrid servo drives. We'll see if it's far enough apart. With all the grounding and all that stuff, I think we'll be okay. If we have any issues, we will take it out of here and put it somewhere else. But yeah, so we're going to go ahead and start assembling the frame, and we'll see how it goes from there. All right. All right, so I wanted to talk about a couple things that we're going to be doing to upgrade this machine. The biggest one for me is these 40-80 C-channel rails. So, I mean, those are probably 1.5 millimeters, maybe 2 millimeters thick.
You know, they upgraded this a lot by using 2 of these C-channel rails with another 40/40 in the middle on the X Gantry, and they're going to be facing each other with that 40/40 right in the middle. It adds a lot of rigidity to the machine, which is better than pretty much anything out there that I've seen that's that you can, you know, buy for a reasonable price for any of these kits, really. So what I've done is I went and found these at Maker Store USA. These are considerably thicker. I mean, that's probably 5 millimeters in some places. That's at least 5 millimeters in some places. And this is going to be a lot tougher. So we're going to use 2 of these on the X Gantry, and we're going to also replace the Y Gantry thin ones with these as well. You can check out the difference in the weight too right here. So let's go ahead and throw this on a scale. So we're going to measure in kilograms, and then we're at 2,040 grams on this, and this is a refrigerant scale. It's fairly accurate. So let's say 2,045 grams. Okay, and throw this on there. Yeah, we're at 3,455 grams. That's a huge difference in material that we're gaining here. Let's go ahead and do a side by side. I don't think anybody's got a video of this yet, but I think it's a fantastic upgrade for what we're doing. You can see that the difference in thickness is massive. These are going to flex a whole lot more than these are. I don't think that this is going to flex much at all. Even if we still use that thinner inner 40/40, we could honestly probably leave it out, but we'll throw it in there for shits and giggles. So that's going to be the X and the Y. And then another thing that I'm going to do, so they use these 20/40 extrusions right here for the base of the machine. Again, they're quite thin. So this is your base. This is what everything sits on. I mean, they do sit upright, which is really good. It's good that they don't have them flat like this, so they are a little more rigid. But we're going to have 4 extra C-channels. So we're going to go ahead and take these 4 C-channels that we have extra, and instead of using these on the base, we're going to use these on the base, which is going to stiffen that up a whole lot more. And another factor is we're going to be using that solid 20 millimeter Tslot plate that we got from Easel, and that's going to stiffen up the machine even more. I mean, I think that's going to have more effect than even using these, just because that's such a solid surface. And lastly, I'm not sure about what I'm going to do with this yet, but I'm probably going to do it later. I may not do it on the initial build, but this is the Z-axis right here. This is what the spindle mounts to. And as you can see, it's the same thin aluminum. And then those linear rails, they mount on here. And if you really look at it, you got a couple millimeters of meat across this whole thing holding that together. And one of the big things that I saw that I don't like is because this is so thick, this pushes the Z out quite a bit, which gives a lot more forces on the X Gantry because it's got more mechanical advantage through the leverage because the spindle motor is so far out from the gantry. I mean, just think about like a pry bar. You know, if you have say if you have a rock underneath the pry bar or something like that, and you have a lot of leverage back here, the longer your handle is, the more leverage you're going to have. So you want your spindle to be as close to that X gantry as you can, and it won't have as much leverage on the gantry for twisting forces, which is the main issue when you're doing aluminum with these machines. So what I'm probably going to do is machine a solid plate out of maybe 1/2 inch aluminum and drop that down. We're going to lose, I don't know, probably 30 millimeters. That's actually kind of big, you know, when you're talking about such a small space. You know, every little bit counts, and I mean we're taking that down more than double, so that should have a big effect. Also, I don't like the way that the rails mount on this C channel here because you don't have very much meat in there, so that's going to definitely cause some flex too. You know, another option, which I'm not sure what I'm going to do yet, I think I'm going to go with the plate. Another option was to get another piece of this, and as you can see, that's much thicker. But here's the problem, and this is why I want to do the plate, is even though this is thicker, right where those rails mount, it's still the same thickness as before. So I don't think that this is going to stiffen up that part of the machine very much at all, which I think that would be stiff enough as it is already. So I still want to machine the plate. However, I may just get a piece of this and mill off this whole top part of the channel and just use this, because I can't find any 80/20 that's thick like this. So I just use that. That'd be great. The only problem is again, the rails are going to have to mount on here, which you still have that thin space right there. So I don't know how much better that's going to be. It should be quite a bit because we do have all this thickness over here, but we're going to have to figure out the mounting on the other side too for that spindle plate. So I might just, like I said, machine a piece of aluminum. I think that'd be a lot better. All right, so that's pretty much it for the upgrades, apart from, you know, future upgrades like the spindle. We're going to definitely upgrade the spindle. You know, I highly doubt that thing is very true when it spins at 24,000 RPM. It probably has a lot of vibration, and yeah, so I doubt it's very round too, and it's not centric. So a higher quality spindle will be quieter because it has better bearings. It'll be more efficient and probably more powerful, even though they say if you got the same rating of a spindle, I think they'd probably be, a higher quality one would actually use more power. Another thing I noticed is the VFD that comes with that spindle is rated for 2.2 kilowatts. And one thing I do know is that when you use a VFD, you want to overrate that for the power of your motor. So if you have, let's say you have a 3 horsepower motor, like I do on my lathe. When I convert that over, I run a 7.5 kilowatt VFD. That way I have enough power to run that motor its most optimal level. So my thoughts on this, I may be wrong, but my thoughts are that I might want more than 2.2 kilowatts of VFD power to be able to run a 2.2 kilowatt spindle, and it'll be easier on the VFD. I mean, worst case scenario, which is best case for me. So yeah, so I think that's about it for the upgrades for now. I did go ahead and buy this stuff prior because I did not want to put the machine together and then have to take it all back apart, because your rails are mounting on here. That's a lot of hardware to be messing with. So if you're going to be building this machine, I highly recommend that you get these extrusions. They're really cheap. Again, that's from Maker Store USA, and yeah, I mean, I think they're $60 each. Super worth it, and it's going to definitely increase the rigidity of the machine. So yeah, definitely get those before you build your Queen Ant Pro V2. All right, so let's go ahead and talk about the control box. This is an option that you can get with this kit. I believe it only costs $300 extra, and it is totally worth it. There's a lot of wiring in here for beginners, and I'm a beginner too, but there's a lot of wires in here for beginners and wiring that's going to be pretty complicated and maybe hard to understand unless you have a degree in electrical engineering or something. I mean, if you can just see the inputs there, each of those has, you know, anywhere from 4 to 6 wires. So there's just a lot going on here, and for $300 extra, these guys will wire this up for you, and they did a pretty good job. Everything's labeled. This is the controller unit. Everything's labeled there. This is the power supply. Probably going to change that out. These are the hybrid servo drives. That's another power supply right there. It comes with an emergency stop and an on and off switch, and then that over here, that is for the DSP controller. I believe it's a dongle, or whatever it is. It's the handheld unit for the control. I got this version because I didn't want extra holes in the box. I'm going to use a different controller, so I only have to deal with that tiny little hole when I remove it instead of a big gaping hole. The cooling fan, it's placed nicely. You know, you got your vents on the sides. I would have flipped those panels over and put those vents on the other side, maybe on the front more, so you have better air circulation in there. One thing I wouldn't have done too is put the VFD inside the control box. You don't want all of that EMF going all over here. I did, however, request something specific, and if you get this kit, I would request the same thing. These do not come with double shielded cables. And the reason why you want double shielded cables is because with any kind of CNC stuff, you need to have protection from EMF. You know, they do come with single shielded, which is just a layer of foil, which does help with EMF a little bit. And when you're doing any kind of like CNC drive stuff like this, anything with stepper motors or servo motors or anything that talks to a computer like this, these control wires are pretty susceptible to EMF. Anything that has a power wire, when the power goes through that wire, it's going to create EMF. So you want to be able to isolate your control wires from your power wires. Even if you have them in separate cables, you'll notice that a lot of places they come together. And when you have these CNCs down the cable chains, they're all sitting next to each other, so they're going to be exposed to EMF from the power wires. So you want a double shielded cable which has a steel braid or a just a braided sheet that goes around the entire cable to collect the electrons and stop the EMF. So the biggest thing about that, though, is that if you're going to do the double shielded wires, you have to have shield drains installed. And a shield drain is where that cable, where it comes out, that shielding, is actually grounded to the box and goes into your wall outlet, and all that EMF is taken away through the ground. So you want to have those grounded. It's really, really important, because if you don't have that, then there's really no point in running the double shielded cables in the first place. And it doesn't work. Let's say the single shield does not work nearly as good as a dual shielded cable. It's a huge difference. So I had requested that they did this, and it was a bit difficult. They kind of got the concept, but you can see these ground wires here. I wouldn't have done it the way they did it, but they did do it a way that will work. Typically, when you ground a cable like that, you have another pin on each of these, and you run your ground to that, so it goes through the connection. What they had done here is not use different connectors with an extra pin. They had grounded, if you can see this wire here, they have it grounded to the body of the plug itself, which is also touching this metal here, which I wouldn't rely on that, but they have it grounded to the body of the plug. And then on the cable, let's see here, on the cables themselves, right here, this is, this little nub right here is the, braided cable, or that braided shroud that goes around the cable, and it's terminated on the plug here. So when this plugs in to the body of this plug over here, it takes that ground through here into here, and then it comes down these ground wires and goes to our common ground, which is somewhere over here. I haven't tracked it down yet. I believe they just have it grounded on this. Let's see if you can see in here on this unit here, which I'm probably going to switch some things around here. I'm going to put a ground rail in there and do my own grounding once I pull this apart a little bit. But one of the big benefits, again, of having the control box, it's not that much money, and saves you, I mean, that could be 30 hours of work or more. Easy. And they probably, who knows, they may have spent that much time on it. But for $300, you can't beat it. And so I'm going to be running the Maso G3 Touch. So because I have this all hooked up, I'm going to, again, make some modifications. All I really have to do is take these wires from this controller up to my Maso. So that's going to be all the wiring I have to do, which is phenomenal. It's going to save me a shit ton of time. It's going to be great. So that's a control box. I think it's pretty good quality. I'm pretty happy with it. Everything's labeled nicely, so you know where everything goes. Not to mention, when you get the control box, they do the wiring on all the servos and on all the end stops. I mean, it's already pre-wired. I don't think you get any of this with the kit. I'm not sure, but I don't assume that they would add all this, because this is part of something that you need to do yourself. So I mean, again, everything's got plugs. I do think that they include plugs like this, but there's no disconnects, or you have to make your own control box. It's a whole thing. And this just saves a ton of time, so that's really, really fantastic. Back at the control box, I mean, it's got plenty of space in there. It's not crowded too badly. The ventilation should be pretty good. They do have a breaker in there, which is awesome. I really hope I don't have to swap that VFD out and put it somewhere else. To start, I am going to be putting a different spindle and VFD in here, but that's going to be outside the box in the future. Okay, so let's go ahead and talk about a couple more things here. We're going to talk about the ball screw, the linear rails, and the bearing blocks. The linear rails look really nice. They are precision ground. There's no play at all. I mean, there's nothing. You can't feel anything in there. They look really high quality. They are HG H15CA on the bearing block. So it's just an HG15, and these are matching rails. They're very smooth, very, very smooth. And I did notice when you push down hard on them, it's even smoother. So definitely a go on these. I'm sure you can get better ones, but these are as good as you're going to need, in my opinion. All right, let's move on to the ball screw. These are beautiful. I mean, they are shiny. The finish is incredible. And there is no movement, nothing, not even a wiggle. So I think these are going to be great. I don't think we'll be upgrading these anytime soon, and if we do, we might just get like a a bigger thread on there so it's faster or something. All right, let's go ahead and see what the consistency is like on these. Go ahead and take our mic out. We're in inches. So let's see what we got. 5850, 5870, 5865, and I'm pushing hard. I got 582, 5825, 5830. So it seems to taper the tiniest bit, but we're talking thousandths of an inch. 5870, 5855, 5875. So overall, I mean, it's within. It's well within tolerances. It's pretty good. That's not going to be noticeable. I mean, this machine, if the rigidity is what I hope it's going to be, will still be accurate within a thousandth of an inch, I think. And that's kind of a dream. Really high-end CNCs are accurate within a thousandth of an inch. We're talking about like big mills, maybe a Haas or a Tormach. That's the kind of machine you need to get that type of accuracy. But I have seen machines like this get accuracies pretty close to that. I've heard a couple people say if you're within 5 to 8 thousandths, that's magical on something like this. So I do have higher expectations from this build because the way we're gonna do it. I mean, it's not a full custom build or anything, but it should get the job done. And we will be doing exclusively aluminum up to 1/4 inch. So yeah, I think this will be great. All in all, it's a win on the rails. It's a win on the ball screw. Pretty stoked with those. They look really high quality, and I can't wait to see how smooth it's going to be. All right, guys. So we're going to get started with the build on this. And the very first thing we're going to do is we're going to locate our cap head screws, which are M4x14, and our T slide nuts. There's a couple different packs of these. One has 25, one has 131. Don't get those confused with the T nuts that are M5. We don't want to be using those on these rails, so it's pretty easy. The shiny screws and the T nuts. We're going to go ahead and grab our linear guides. I went ahead and put these in little bends so they're easier to get instead of pulling them out of the bag every time. We're going to go ahead and put a screw in every hole of the rail, and we're going to put a T-nut on there as well. So yeah, we're going to go ahead and put a T-nut and a screw in every single rail. We're going to do 4 to start, just get ahead of ourselves so we have everything for the Y gantry. You want to make sure that you put the screws in the recessed hole on that side, and then make sure that the T-nuts are placed properly. You want that little groove facing towards the rail. There's a little groove in the T-nut there. Just a quick tip. You're going to want these T-nuts to be hanging on by just a couple threads. If they're too tight or too loose, it's going to be a nightmare to slide them into the T-slot. So yeah, just a couple threads at most. You don't need many. It's definitely ideal to have a gap right about there. Okay. All right, so just like our buddy Roger Webb, who has done a build video on this, we're gonna go ahead and install these linear rails on this side of the C-channel, not the weaker side. I totally agree with him on that. And to do that, now that we have our nuts and our screws lined up, we're gonna go ahead and line these up and slide them in. Which is gonna be easier said than done because you have to line up every single T-slot. And if they're too tight, they're not gonna go in very well. So we're gonna go ahead and do that and be right back. Okay, so now we can move on to tightening down the rails. One thing I wanna note, I've seen a lot of people use these right here. These are just the linear guides, which will work great. What I'm gonna do, however, I haven't noticed anybody else do this except for custom builds, people who have built a lot of these machines. We're gonna go ahead and do one rail with these linear guides. We'll do the other one, but we're not going to tighten it all the way up. And then we're going to put one of the bearing blocks on here, and we're going to mic it out. So we're going to measure how parallel these rails are with the gauge, with the dowel gauge, and make sure that the opposing rail is absolutely perfect all the way across. To get these linear guides on, what you want to do is you'll notice that there's a groove right here that goes in the T-slot. You put one on the end, put one in the middle, put one on the other end, and you want to tap these in with your hand. Go ahead and insert a T-nut into there and take another bolt. My wrenches are magnetic, so it pulls the T-nut back out, so I just use the bolt. You get that in there and cinch it up nicely. And then what you're going to want to do is you're going to want to pull the rail towards the guide and cinch it down. Do it the same thing in the middle. And then one on the end. And cinch it down. So what I'm going to do next is, instead of just tightening these up, I'm going to go ahead and move these guides to the center here and do the same thing over here, just in case, so I can get that perfect. All right, so I've moved these to the center, and then we're going to go ahead and do the same thing again. I'm going to go ahead and cinch it up, and then we're going to come through. I'm going to go ahead and adjust the torque on this. We're going to come through and tighten all these up now. All right, so this rail should be set pretty true. We're going to go ahead and do the same thing on the other side, but we're not going to tighten it as much. I'm going to reduce the torque on my driver as much as possible. That way I can get a little bit of movement with tapping after we go ahead and put a linear guide on here, and we take our tool and we measure. So my suspicions were correct. After I threw on this dial indicator, we've got a pretty good deviation. Now this is in thousandths, so that's about 5 thousandths of difference. And then we go to positive 10 thousandths nearly, so that's 15 thousandths of difference. If you want extreme accuracy on your machine, you're going to want to get this as good as possible. You'll notice at the ends it's pretty close, but it goes in and out in waves in the center. I don't know if it's the side that we started first that's all tightened, or if it's this side. But we're going to go ahead and we have to reference from one side, so we're going to reference from this side over here. Okay, so here's how we're going to fix this. So we didn't tighten these up, we only tightened the ends up and where the bearing block is. We're going to go ahead and pull this to where it zeros, and we're going to tighten it up. Alright, now go a little bit past the zero. We can tap that back. Now it's zeroed out. We come back and check, and we don't have much movement at all. After zeroing just that one part right here, our dial indicator is not moving but a thou, maybe two along the travel. That really helped out a lot. So we're going to go back and we're going to loosen and tighten every screw until everything reads zero all the way across. For this next part, we're going to go ahead and put together the chassis. If you're going to do it my way with using the extra 4080 C channels for the chassis instead of those 2040s, you're going to need to get 8 more of these 2020 corner brackets. They're the 90-degree heavy-duty ones, and you're going to need a little extra hardware. So for the traditional build, we're going to need the black angle corner connectors, low-profile screws M5x8, the T-nut M5s, and the double L brackets. We're going to want to take 6 of these M5 T-nuts and slide them into each T-slot on the side of your C channel. And then you're going to take your M5x8mm low-profile screws with one of these angle brackets. Make sure that the first one that starts on the end is facing this way, because the channel is going to come out this way. This is going to bolt to one side, and then the faceplate will bolt to the other side. And then you will have 2 in the middle, and again, the same thing on the end. Don't tighten these things down, because they'll be hard to move. Also, you'll notice that these brackets have offset holes. Some are closer to the corner, and some are further from the corner. The ones that are further from the corner are the ones that are going to go on the C channel. Now we want to set the C channel this way facing up, evenly across. Go ahead and go through and put a mark
every 333 millimeters. Just 2 in the center, really, on both sides. And then you want to take the C-channel and center that center hole right over. It doesn't have to be perfect, but just get it centered on each hole on both sides, and then we can go ahead and lock this down. Shortly after, we're going to go ahead and enter 2 of those M5 T-slot nuts into these T-slots and take those same low profile screws and tighten them down. Don't tighten them all the way. We want to be able to move the frame to square it up. In order to use the larger 4080 C-channel for the base of the frame here, we're going to have to cut them down to the same size as these. So we're going to go ahead and pull one of these over. We're going to put it on the saw and we're going to cut it down. Now we want to set the C-channel this way facing up, evenly across. Go ahead and go through and put a mark every 333 millimeters. Just 2 in the center, really, on both sides. And then you want to take the C-channel and center that center hole right over. It doesn't have to be perfect, but just get it centered on each hole on both sides, and then we can go ahead and lock this down. Shortly after, we're going to go ahead and enter 2 of those M5 T-slot nuts into these T-slots and take those same low profile screws and tighten them down. Don't tighten them all the way. We want to be able to move the frame to square it up. Go ahead and grab yourself a decent square. You're going to want to bring this up inside here, pull it up flush, and make sure all 4 of your corners are square. And this is just the start. I've already done all 4 corners. Make sure that these are just barely tight. You want the sides really tight, but not the bottoms. We're just doing the outside C-channels. We're not doing these yet. Those don't really matter as much. But once you get these really square, then you can tighten this up a tiny bit. But the last thing we're going to do is we're going to measure from corner to corner in both directions, and we're going to compare those measurements. They should be nearly exactly the same measurement. If they're not, then you can perfect your square with that. Alright, here's something I want to show everybody. This is fully tightened down, and you can see the gap in there, right there. Go ahead and get a mallet and tap it down on all your channels. You want to make sure that those are nice and flat. Otherwise, your bed's not going to be perfectly flat. So we measured across from this way and this way, and we're exactly 55 and a half and 3/16. So it's exactly the same measurement. That just shows that the square that I have right here is actually fairly decent. I think I paid like 30 bucks. It's not a really expensive square, but it did the trick. So everything's squared up, everything is flush. We're gonna go ahead and tighten these down a little bit more. We're gonna center these on our lines that we made, and you'll see the center of the channel here. You just line that up with the line, and then we're gonna tighten all these down nice and tight, and we're gonna flip it over. So we've got it flipped over, and we're gonna go ahead and check how square it is one last time. So we're gonna butt this square up in here nicely, and we're gonna run it up against here. As you can see, we are pretty damn square. So I think that's good. On to the next step. Okay guys, so now we're on to the X Gantry. This is what you're gonna need. You're gonna need both end plates for both sides. And you need 8 of these linear bearings. The bag of 5 by 15 millimeter low profiles. The 5 by 14 round heads. And the M4 by 32 cap screws. You'll need 8 of these bearing block adapters. 2 of these ball screw adapters. And the end plates. First thing we're going to do is we're going to mount this to one of the ball screws and then mount that to the plate. Go ahead and take 6 each of these M5 low profile screws and tighten them up nice and tight. Make sure this hole is on the top. Okay, we're going to go ahead and grab our mounting plate.
You notice that all the holes are on this side and the recess side is on the outside. So this is going to be the back of the machine, and we're going to go ahead and face those holes towards the back with the recess facing us. When we get the cap screws installed, make sure that we don't tighten them up too tight because we're going to have to adjust this. Also, make sure that the reduced taper over here, or the reduced part of the shaft, is towards the back of your machine because that's where your servo motor is going to mount onto. Next, you want to slide on the 4 linear bearing blocks. You want to take the M4 32mm screws and put them through into here with using the spacer. Make sure you keep it nice and loose so it's easy to put on, and you want to be able to have this loose when you install your X Gantry. Go ahead and do that on both sides. In this next step, you're going to want to go ahead and get out your 5mm by 20 low profile screws and get your end caps. So this is the back of the machine. I just put the front cap sitting over here to hold the rod up. If you set it like that, it'll hold it up so you don't have to cut a piece of wood. And then we're going to go ahead and put this on the other end here. And you want the recessed part, not that flush part, the recessed part facing towards us. So we just go ahead and slide that on there like that. And we're going to take our 5x20s and we're going to put them in here. And then shortly after, we'll get us some Tslot nuts. And we'll do the same thing over here. Okay, so we've inserted this 2040 Tslot extrusion into here. And we tighten these up. These are just finger tight for now. We're not going to go full tight on them. Something I did notice though, they provide you with a 5x16mm cap screw to do this. And there's not enough thread on there for it to grab this. So we're going to put these in backwards and we're going to get a whole lot more bite. So we're going to go ahead and put 6 in total. We're going to do 3 on the top and 3 on the bottom. You can use a screwdriver to move them around so you can get them lined up. We're going to get those bolts in there and it should be good, and we'll tighten them all up, including these. We've got those all tightened up, and that now works much better than before. Once you have everything tightened up on all 4 corners, go ahead and grab yourself a pair of snap ring pliers, 2 of the 4 provided circlips, and snap them on the ends. Okay, so next step. We're going to go ahead and take these M5 by 8mm screws. You're going to need some Tslot nuts that swivel in. These are the types that you can just put in the rail without actually having to slide them in. And we're going to go ahead and use these extra corner brackets that we got, and we're going to tighten these up onto each rail. You can put the T-nuts on the screws inside the block like this, and when you place it on the rail, they'll slide right in. And when you turn the screw, the nut will turn and lock itself in. On this part of the X Gantry, you're going to want to go ahead and attach your linear rails to your C-channel on the back side, just like we did on the other one. It's funny because it would be reversed in the stock setup, and then you want to put one on one side on the other one, and go ahead and slide 2 linear bearing blocks on each rail, and we will move forward. Go ahead and join the 2 pieces of the C-channel and put the 4040 extrusion in the middle. Slide 16 of those nicer Tslot nuts into the channel, and we're going to go ahead and center 2 of these on the top side of that. When we're done, we're going to roll it over, add 8 more Tslot nuts in the bottom side, and put 1 more of these directly in the center. That one's going to be on the bottom. Quick tip. Before you cinch these down, throw a clamp on there and get it nice and tight. You want these C-channels to be really tight against each other. It'll be more rigid if they are. And don't forget to butt up your ends. You want it as flush as possible on both ends. As we come over here to the other side, go ahead and put another 8 Tslot nuts in there for this. And you can see that there's a gap in between there, and if I squeeze it, the gap closes. So use your clamp again. This last one on the underside goes directly in the middle. So after having a look, my thoughts are this. On the bottom of this X Gantry, the spindle is going to be twisting from the bottom up, and I feel like it's going to have enough pressure to be able to separate these. So what I'm going to do is I'm going to order a few more of these plates off of Amazon. I'm going to go ahead and enter those Tslot nuts now. I'm at least doing 2. So 3 on the bottom, 2 on the top. I'm not sure why they have only 1 on the bottom when that's really what's going to take the force as the spindle's being pushed in either direction, particularly if you're milling aluminum. So I'm going to go ahead and put 8 more of those T-slot nuts on either side. I did go ahead and buy another pack of 100 for this job, so I'm going to insert those now so I can put the other plates later when I get them. So the next step in this, we're going to go ahead and assemble the ball screw nut block onto the ball screw here. Just the way we did it last time, we're using the same hardware. And then we're going to attach this plate onto this ball screw nut block the same way we did last time with using the same hardware. Remember not to tighten it down too much because we got to move it around. Next up, we're going to go ahead and take the M4 32mm screws, our bearing blocks on our linear bearings. We're going to go ahead and put this on top and mount that to the X Gantry. Remember to only go finger tight because we want to move this around later. Go ahead and flip the gantry over. Grab your bag of 4mm by 10mm screws, and we're going to attach this back plate to the rear part of the X Gantry now. We're not going to be using the blocks on this one, so that's why the short screws. Once you have that mounted up, still loosely, you're going to grab this bag of M6 by 16 screws, and we're going to put this plate on the top of the gantry. Okay, so go ahead and take your 90-degree angle bracket, take some of those nylon lock nuts and these M5 20mm low profile screws. Go ahead and install those on either side of the X Gantry there, and only tighten the end bolts. If you tighten them all, you're going to have to probably loosen them later, so just tighten the end ones. And what we're going to do is we're going to take the X Gantry and we're going to set it on top. We do have to get the ball screw in the bearings, so you want to make sure your plates are nice and loose on both sides. That way we can wiggle it in. Okay, so now we're going to set the X Gantry up. I did realize that I had this bracket in the wrong holes, so go ahead and move that to the second set of holes up. Make sure the bracket is facing upwards. And we're going to go ahead and get this X Gantry mounted. Well, that was pretty easy. Let's go ahead and put some bolts in. Now you can grab the M5 by 20 screws, the low profile, and we can pretty much fill every hole here. So I'm not going to go too crazy into detail about squaring up the machine. You can find that all over the internet, really. But you want to loosen pretty much everything up and make sure that that X Gantry is square with your table, if your table's flat enough. This table has 2 layers of 3/4 inch melamine, and also has a lattice frame underneath. And I used really fine, really nicely cut wood, really well finished hardwood underneath there to do a lattice crisscross frame in there to hold everything together. In fact, I'll just show you. So yeah, this table's super flat. Ultimately, the goal of that is to get your X Gantry plate square with your frame on the bottom. That way it's going to be square with your work. And this is one of the biggest ways to do that, is by making sure this is square. However, some of it's in here too. There's not much movement when you loosen all those up. This thing will, it'll move maybe 1,000th or 2. It's pretty tight in there. Another thing, when we do this, when we tighten this up, we want to make sure that this is also square this way before we cinch it all down as good as we can get it. That way we don't have to go crazy with tramming later on. I did notice that one of these was slightly shorter, one of these, fractions of a millimeter, and I had to shim it. Get yourself a nice pack of shims. You're going to need them. You know, if anything's not perfect, you know, throw a few shims in there and you can get it perfect. And when you put your spindle on, it's highly likely that you're going to have to shim that too to get it perfect when you go to tram your machine. Another quick tip here, when you go through and tighten all these bolts, because there are so many of them, you're going to want to go back through a couple more times and tighten them up again, because as you're tightening these, some of these will loosen, and as you go down the line, even if you do a crisscross pattern, other bolts will loosen up as you go. So go through it 2 or 3 times on each side on pretty much most of these things, but mainly this, and just tighten them a couple times. We're going to go ahead and square up the X Gantry this direction now. Your table is perfect to use. If you're using the same rails I am, great, because they just happen to be right underneath it. You may have to use your table, but if your table's flat, this should be fine. You're going to have to trim this in later anyway, likely. But we're going to go ahead and square that up now. Loosen every bolt front and back except for the top 3, the big ones with that support that goes between the 2 sides. And then hold it square and tighten them up slow. You want to be able to tap it around. So I just tighten up maybe 2 of those bearing blocks on 2 bolts only, and then not too tight, and then you can just tap it to where you need it to be, and it'll actually stay versus fighting it. You're going to want to grab the nuts that go on the end of the ball screws. Go ahead and tighten them finger tight, pretty much as tight as you can with your fingers. That'll be good enough. Don't over tighten them. And then set that set screw. There should be one more on each nut. Go ahead and do that on all axes, and that'll hold the ball screw in place, and you make sure that you don't have any backlash. You can wiggle it around if you want, but if you get it finger tight, you shouldn't have any backlash whatsoever. Once you're done with that, you should be able to turn these by hand. In fact, I'm moving the entire Y gantry, or the entire X gantry, in the Y direction by turning 1 screw. That's how you know that you're nice and true. Once you're squared up, that's how it should be. I could go to either side and move the whole gantry. And then you want to come check your other axis here. And I mean, I can easily move that around. And go ahead and do the full travel just in case, because you might have tight spots. I did. I had tight spots down here and a tight spot down there. And the way that I fixed that is I loosened all this up. I did that prior, by the way, before squaring it. I loosened all this stuff up and moved it to the tight spot, and then tightened it back up. And when it moved back to the spot where it was okay, it still worked perfect. So I got rid of that tight spot that way. And it's really important that everything's nice and square. And if it is, then you shouldn't have any bad tight spots. You're probably going to still have a tight spot, and you're going to have to fix it that way. One other thing I did notice, so when we line these up, we use the linear guide thing, the little blocks they give you, and we went ahead and used a micrometer or an indicator tool, and we indicated the whole top rail. So we had one reference, which was just with the blocks, and we indicated the other rail to it perfectly. However, when I got to this end of the travel, it was binding up on this axis, just on this side, just a little bit. So what I did is I moved the gantry all the way here. I just loosened these through 3 screws before I did that, and then I tightened them up once it was over here, and then that corrected that binding issue. So I just test fitted the bed just to see what it'd look like, and I got lucky. I didn't have definitive dimensions, and that was an issue for me. But I mean, I'm losing an inch on either side, which I'm totally fine with. That Tslot bed, I mean, it is pretty, and it's precision ground. So that being said, it's going to be incredibly flat once we get that thing locked down. Yeah, I really like it. I think it looks fantastic, and it's going to add to the rigidity of the machine. At least help stop things from moving. This being a solid surface, it is in 2 pieces, but mostly solid surface. Things aren't going to move around much, I don't think, at all. And having the double width down here with twice as many lockdowns is going to really help too. So I'm hopeful. I think it's going to turn out great. You're going to want to go ahead and get these angle brackets done. You go ahead and take those 5mm by 8mm low profile screws and the T-nuts that slide in the rail, not the thicker ones
lower quality ones, and go ahead and fit those on there and slide those in. Get that done top and bottom on both sides, and then we can go ahead and start on the Z-axis.
Now we're going to build the Z-axis. We're going to do it the same exact way we did the other axes with the same exact hardware. So one thing to note, this is going to be the top of the machine. And you want these little holes right here, see how they're off center? And you'll notice that these are actually further towards this part than they are over here. So you want these holes to be towards the top over here. Go ahead and put it together. Okay, so we've got that mounted, and remember again, we want to keep it nice and loose. We have a top and a bottom plate here. The top plate is the one that has the motor holes. The bottom plate goes here, is this one. You want to put the top plate up where you have the longer part of the shaft here. So this is going to go like this, and then this bottom plate is going to go on here like this. All right, now that we've got that mounted up, we're going to put the top and bottom plate on. The top plate has the threaded holes for your servo. That goes on the part of the shaft that's reduced. So we'll go ahead and get those on. You want to grab your 5x15 millimeter low profile screws and go ahead and lock that down. We got the ends on, but this extrusion was cut just a tiny bit short, so I had to put shims on both sides because the ball screw was binding, but now it's super smooth. Now we're going to set this top plate. Unfortunately, all these screws will be inaccessible once we get the plate on the X axis right there. So here's a little trick that we're going to do. So we know that these are flat and these are parallel to this. So we're going to go ahead and back this up to where it flattens out, and then we're going to go ahead and tighten everything up. And that should keep this parallel with this. That way when we put it on there, it'll be mostly square, hopefully. All right, go ahead and take your M6 high duty screws. They're M6 by 20. That's what they call them, high duty screws. And mount your spindle axis there. One thing I did notice when I first mounted this up, it was not perfectly square. So what I did is I pulled it back off. I loosened every screw in the back and only slightly tightened the corners on the bearing blocks, just slightly. And the reason why I did it that way is because I put it back on, I put my square up and I can knock it into place, but it wasn't loose enough to come out of place, so it stayed in place. So I knocked it into place, I pulled it back off, cinched everything up, and then put it back on, and now everything is perfectly square. Go ahead and grab your spindle mount. Get the hardware out of the box that it was in. You'll have an 8mm screw, a 10mm screw, and the slide-in T-nuts. You're going to want to use a 10mm screw on these right angle mounts, and you're going to want to use the 8mm screw for the T-nuts. Once you get these mounted, you don't want to do it too tight, but once you get those fixed down, you can go ahead and put these 8mm through these holes over here with the T-nut on here, and you can place it up here on your Z-axis. All right, so for assembling the servo motors onto the axes, you're going to want to grab 4 of the long spacers, 4 of the short spacers, 4 of those 65mm screws, and 1 of these couplers. Okay, installation of the servo motor is pretty straightforward. You put the spacers on, you put the screws through, you put the collar on. The only thing that I would note is that the servo has a flat spot right up here. You probably want to align that split in the collar on that flat spot. That way the rest of the collar has even grip around the entire thing. Apart from that, it's pretty straightforward. Besides maybe the cable directions, this is the back of the Y here. We got the cables going this way, and then this one is going this way, so it all can meet the cable chain. This one's going down, and the Z is going down. All right, guys, so that's about it for the mechanical build part of this series. I really just wanted to show everybody how to incorporate the improvements that I've made to the machine. I really hope that that helps with the rigidity. I'm fairly confident that this is going to make a significant difference. I'm pretty sure that I'm still going to try to thin out that Z-axis. It is far too far out there. It's terrible. If you liked what you saw in this video, please like and subscribe to my channel, and stay tuned if you want to see more. Happy holidays.